Well. This is WeatherBrains episode 596. This is for Monday, June 19th, but we're recording this on Thursday, June 15th. It's vacation season. This is that wonderful time of the show where we share boring personal stories, humorous anecdotes, and occasionally say outrageous things.
I don't think I have any of those tonight.
I've always got a boring story. That's one thing about me. I've always got a boring story because I am a very boring man.
Whatever.
Goodness gracious, the sunset. It's just been one of these weather days where we had storms where we are through the afternoon, and then the storms moved out about the time the sun is coming down, and it is just stunning. It's amazing out there. And I've never had a window. My window to the world is all these tweeter pictures. So there you go.
That's good. It's not a bad window.
And I have a funny feeling I haven't done something here.
I
know I've got to write a discussion. I never got the afternoon blog thing going because the severe weather started to crank up about 2:30.
You need me to do your facts tonight?
I got it. You cover this. You cover this, and I've got. I'll take care of that. And VBS.
Is that
man? These sunset pictures are unbelievable.
Yeah, I need to get over there on your Twitter feed.
The ones from Regents Field, downtown Birmingham, or the Barons game, are just it's surreal. I mean, it's. Yeah,
that one is
the ones,
beautiful. Wow! Oh,
it's just surreal.
Field is beautiful.
The days I wish I had a window. Kevin, you look tense, man. We can't. He's not talking to us. He has something going on in the studio. He has to have his microphone turned off.
He's been silenced.
Okay, can anybody hear me?
Yes, we can, Sheldon.
Oh, that's wonderful. That's half my problem. Oh, and there's Dave. God.
You fixed your microphone situation.
Oh yeah.
Hey Sheldon, can you tilt your camera down just a smidgen? We got too much headroom. We're in the lower part of your face being cut off a little bit.
That's because I got a lamp. Okay. How's that?
Oop, that's worse.
Other way. Go down.
Oh, I'm going
there
up.
You go.
Bingo.
Now you
bingo.
Oh.
Now.
You got to remember, I'm retired, and I don't do this too often.
Well, I'm retarded, and I don't do this too often either. I don't know anything about it.
Okay.
Dave, you hear us okay?
Hi, James. Yeah, can you hear me okay?
Yeah, man.
Sound good, Dave.
Look
Awesome.
good, sound good. Camera's right on the money.
Here, I thought he was going to do it from the beach. That's what Dave said.
I am at the beach, but I'm not on the beach.
Oh, right, on the beach. That's because it's too
It's
dark.
better to be at the beach instead of being on the beach.
Yeah, under's not good.
So
will I be able to share my screen at all if I want to show any visuals? Is there a button?
Absolutely. It's in
there's a little
to the left side of this. It has a little green rectangular screen that has an arrow pointing at it. It's called screen share.
Okay.
And when you click it, it's gonna give you it's gonna ask you if you want to show your whole screen or if you want to show an application window. And so you generally will pick an application window, and then it'll show you all your applications you have open.
Okay.
Let you pick one of those.
Can I test one?
Yeah.
Okay. Oh, hey, let me do something over here for a second. Let me just drag.
So Brian, I think he's back. I saw he took a company car to Jackson. He's back, but I guess what a weenie. Come on, man.
You wonder why people don't want to come on this show.
No, he just drove over to Jackson, Mississippi. It's just like one state over, and it's not like you're driving to Seattle.
Can't say that in Texas. But.
That's true. You can start out in West Texas in the morning and still be in it that night.
Yep.
Bill, I'm trying to figure out where I'm going to do the screen share. What exactly?
Left side. There's some
Left.
icons over there. The
Yeah,
second one down is a green
Dave-
rectangle.
Dave, we're seeing your screen share fine. You look good.
Okay, great. Thanks, James.
I guess I don't see a screen.
You don't see some icons on the left side of your
Oh
screen?
yeah,
It's a
yeah,
little,
yeah. Oh, it's the
it's
green.
this-
Okay,
yeah.
okay,
Yeah, the green one with an arrow on it.
And it'll
okay.
look like what we did in the test, except it's just on the other side. In the test, remember, it was on the right side. But on the real show, it's on the left side.
Should I click on it just to see whether?
Yeah. Good practice.
Okay.
Just like we did it yesterday.
Right, and where would I click?
Did you click the screen share button?
Yeah, I click.
Okay. Then it'll say, do you want to share your whole screen, or do you want to share an application window?
Well, I see full screen. I see Google Hangout. I see info. Oh.
Yeah, pick your browser that you want to use to show whatever it is you want to show, like Mozilla, Firefox, or whatever.
Oh.
And then start sharing.
You do not hear audio, right, with any videos playing?
No, we only hear your mic. We don't hear if the browser's playing a video or some audio. We can't hear that.
Okay.
We see you now, Sheldon. You look
Okay, you
like
see
a
that?
big thunderstorm with an overshooting top on it.
Yeah. Okay.
Yep, that's what we see.
Okay.
This Go 16 stuff. It's addicting.
Yes.
Yeah.
I'll sit there and play. I'll play with this stuff way too late at night.
It's making you a better meteorologist, James, man.
Man, I heard
Possible.
I heard a guy, up in he was from Wisconsin, Scott
Bachmeyer.
Scott Bachmeyer. Yeah. University of Wisconsin Sims. Yep. Scott Bachmeyer.
I guess it was him.
Yeah.
But he spoke in Chicago, and man, it was just mesmerizing. I can't wait for this show here. So we can get started because we're not on television. This will be on television, but it's going to run Monday nights. So, in fact, they're probably going to run the whole pre-show because they don't even know when to start it. So I would imagine we are on television right now. So for our friends watching on television, hello. We recorded this Thursday of last week, back on June 15th, due to a vacation schedule here. So we welcome you to WeatherBrains, and the gang's all here.
Play back the YouTube video?
Yes, they just play back they go to live.bigbrainsmedia.com, and whatever's there, that's what goes on television. And typically it's live. And these .2 things are all automated. I mean, at 30 after the hour, they do a commercial break. 28 after, they do a 2-minute commercial break. Whatever's on that live stream goes on that .2 channel. So scary proposition. But let's do this thing. We are Red Eye. Let me find I got so many windows and screens open here. All right, let's do this. And let's do this. We are now recording, and here we go in 5, 4, 3, 2, 1. Hey, this is WeatherBrains, the weekly show that's all about weather. This is episode number 596, and this is for June the 19th, 2017. Thank you so much for taking the time to join us right here in the midst of summertime. This is James Spann. And let's just, we're transparent on this show. We wear our hearts on our sleeve. No secrets. We're actually recording this show on Thursday, June 15th because of vacation. When you listen to this, I will be somewhere in Florida or in Missouri or Kansas. We've got...
Wow.
Depending whether you're coming to the airport or not.
That's true. I'll spend a few days in Florida with my lovely wife. We have not had a trip together to the beach without children since 1984. So this will be almost like a new honeymoon or something here. And then I go to the AMS broadcast conference in Kansas City, which should be a ton of fun. And if you're there, be sure and stop by and say hi. Everywhere I go, I'm shocked. In fact, it's scary at the number of people that listen to this show, Kevin, and they love you.
And who did you say was going to be in that super secret meeting that you're going to there?
Well, if it's super secret, I can't disclose the information. I'll have to break your legs or get Moose and Rocco to break your legs.
I don't know.
Executive privilege. You'll be good, James.
I don't know how we're supposed to assign any credibility to this unless we know who the players are. Bill, are you going to this meeting?
No, I wanted to. I got invited, but I didn't get to go.
You know, I once gave a talk at the AMS broadcasters meeting back in the early 2000s. So I know something about that conference.
Well, Sheldon, you should come back sometime. In fact, I'll be the first to say I have not been to an AMS broadcast conference in 2 years. I've skipped a couple of them. Last one I attended was in Nashville. But no, it's going to be a lot of fun, and we'll take a group picture, Kevin. How about that? And if anybody needs their face blacked out, we'll just black out their face.
Bill's invited, and you just invited Sheldon, but I'm not invited.
You, sir, have an open invitation. It's not that far.
Well, let's just put it this way: James didn't invite me. No.
Oh, you were just you knew where it was.
No. This meeting, I am not the facilitator here. I'm just the instigator.
Invited because whoever's involved wants to see if they can get a little help with the hotel meeting room. You know, so, hey, Bill, can you help us with this hotel deal? Oh, yeah. By the way, you're invited.
Yeah. So anyway, thank you for joining us, and obviously we have Kevin Selle, who is the chief meteorologist for KFDX Television in Wichita Falls, Texas, on the line, better known as the Accelerant.
Just watching some dry line thunderstorms weaken as the sun goes down here, and that's about it, really. It's pretty quiet.
So did you get any response from your prepared statement on the last show?
I had a couple of tweets from, listeners, but anything formal from anybody mentioned, no, not a peep.
Oh, okay. All right. Well, we'll be standing by for news on that. But Bill Murray, let's just go right to it. We got some important guests here. Let's start this show. I can't wait. This is going to be a good show.
Yeah, James. Tonight's guest, WeatherBrain number one, is the founder and CEO of Storm Center Communications. He's an AMS fellow and a former broadcast meteorologist from NBC4 in Washington, D.C. He's Dave Jones. He's going to discuss some of the innovative applications of GO16. The workshop for broadcast meteorologists held at the Kennedy Space Center. New technologies available to deliver geospatial data, including satellite data, decision makers and forecasters in the era of impact decision support services. Thank you for that nice intro there, Dave. That tells a lot. So you were on TV in Washington, NBC4. Let's share.
I worked closely with Bob Ryan for a number of years. I was there from the early 90s, about 91 to the end of 2000. So worked with a lot of great people. Willard Scott was in the same building when he did the morning show there from the Today Show, and also Tom Kirine. Lots of great memories there. And actually, before I was on the air at NBC in Washington, I used to work for, anybody remember this company, ESD Weather Systems?
I should know that name. It rings a bell, but I can't place it.
What did they do?
ESD, Environmental Satellite Data, created the first basically front-end satellite receiver to put satellite images on TV.
Now, did you guys use like a Krememco piece of hardware to do that?
I think that might have been, remember Color Graphics?
Yeah, well, see, that we did business with those guys, and I don't know if ESD had something to do with these guys or not. The ESD rings a bell. And this was back in the 80s.
Right, exactly. Back in the 80s, and ended up WSI bought ESD and then merged the companies together. So it all became WSI. And I helped to design some of those on-air weather graphic systems back then.
That is awesome. So we've got lots of questions for you, and we can't wait for all of your information tonight, Dave. But guess WeatherBrain number two is sort of a cult hero on WeatherBrains. He's a WeatherBrains fellow after 596 shows. He's retired from over 35 years of service for the National Weather Service, working in Nestus, where he analyzed satellite data, and we all saw his name at the bottom of discussions for eons. But he's going to discuss GO16 and the NOAA polar orbiting data and how it helps forecasters, and how innovative applications are also going to help forecasters from this remote sensing. So Sheldon Custelson, welcome back to the show.
Thank you, Bill. I remember well when I did your show back in May of 2010. I think it was about the week of the Nashville floods or shortly thereafter. And that was an interesting time talking about satellite data, and I think we talked about GOES-R back then, and it was long in the future. And as an operational person, they don't get you to provide very much information to you because you're still working on the old satellites. But I was able to go a few years to the Comet workshops in Boulder to learn more about coming GOES-R, and I was a strong advocate for also including the polar microwave imagery to use in conjunction with future GOES-R. So now that it's here, it's great.
Yeah, it's funny. I had to pull out an old WeatherWise magazine to look up something the other day. It was the anniversary, either early this week or last week, of the Little Sioux Boy Scout camp tornado back in 2008. And I opened the WeatherWise Almanac edition, and there's a huge ad from Raytheon talking about the coming GOES-R and how huge it was going to be. So, I mean, that just tells you right there how long we've been waiting on this thing. 'Cause, I mean, we were having workshops in 2011 at NWA, and I know there were probably things before that. So, this thing's been a long time coming. Is it going to be worth it?
I certainly know it's going to be worth it. And Bill, these satellites, these new generations of satellites, take 10, 15 years to develop. So and come to fruition. So I remember back in the 90s when the current generation of GOES satellites were thought about in the 80s to develop, and so they take a long time to develop the instruments and get the feedback from forecasters as to what they want to see and things like that. So now that it's here, it's great.
So Sheldon, what year did you start with the Weather Service?
Well, I started with Nestis in 1979, but I really go back to 1975 when I worked the summer in Nestis, and those kind of were the halcyon years because I would learn from the people like Jim Purdom, Rod Schofield, the Roger Weldons. Those were the kind of the fathers of geostationary imagery, and we'd have map discussions every day at 10 a.m. in the Nestis research area, and that's where we started to learn more and more about geostationary satellite imagery and how to interpret the data. So I kind of feel like we've kind of come a long way, but now with 1 minute and in some cases 30-second data, we have to relearn some things about how to look at the imagery and use it to its best potential.
And so when you started in 1975, was that an ATS satellite? Would that have been the main primary satellite, or what?
That was SMS-1, which had been launched in May of 1974. Believe it or not, a month after the great tornado outbreak. And then SMS-2 was launched in 1975 so that we have east and west locations of the satellite by October of 1975. My summer internship finished in end of September of 1975, and then I went on to AccuWeather for a few years to learn the ropes of really forecasting the entire country before I returned to Nestis in 1979.
So just a month later after the super outbreak, I remember there was some reference at some point, and maybe you can correct me, Sheldon, but they had to ask for special permission to use extended hours on the day of April 3rd. For the old ATS satellite or something, so they could have images past the normal time or something like that?
Well, that I don't know because I was still in college then.
Were you at Penn State, right?
Right, I was at Penn State, and the biggest recollection that I remember from that great tornado outbreak was that 2 days before there was an incredible pressure jump in State College, way out ahead of this tornado outbreak, and temperatures in southern Texas were in the upper 90s, close to 100, and that was the kind of air that was coming northward and going to feed these storms. And we were all up in the weather station at State College at Penn State, and we kind of had a feeling something was going to happen, especially when we saw that pressure jump. But we could not know what kind of tornado outbreak was going to occur the next few days in the Ohio Valley.
It was an amazing night, even here in Alabama. So Dave, I wanted to ask you one more question before we get into looking at the satellite information you guys have prepared. Where were you when you learned about the internet, Dave?
Well, you mean the internet that Bob Ryan and I created?
Yeah, there you go.
Oh, brother.
That was back in actually, that's a great story. 1994, I was at NBC in Washington, wrote a proposal to NASA to increase the use of Earth and space science data over this thing called the internet.
Exactly.
Small I, not capital I. And so we won actually funding. I won $2.3 million.
Oh my goodness!
From NASA.
Wow.
When I was doing the weekend weather at NBC in Washington. So needless to say, I became a full-time employee. And,
I can remember when Jay Shepard, we were working on programs in C+, and when he said, "Hey Bill, you need to be looking out for this thing called the internet," that would have been 1994 too. He said, "It's going to be the information superhighway." And I would tell everybody I knew, this is information superhighway coming, and, you're going to order pizza online, and you're going to, all this stuff is going to happen. And they looked at me like I was insane. And now we don't know what we would do without it. So talk about what your company does real quick, Dave.
Well, here's a great, let me mention this too. When we first created WeatherNet 4 in Washington, D.C.
The first website on television for a television station, weather department, right?
It was the first weather website in the nation. Yeah. In 1995 is when we launched it. At the same time, Steve Case, you may know that name, was mailing out his AOL discs, right? To every home saying, sign up for the internet. It's free. You've got mail, right?
Oh,
and so then we started putting things onto WeatherNet 4 and telling people to get onto the internet to go and see things like our forecasts or satellite images or our tower cam. And so it was pretty wild. When I would do a weather update, I would tell people to go to the website, then I would scoot my chair over to the left, and we had the server right there. And so I could see our viewers coming right in and hitting the website immediately after I would tell them where to go. And so it was pretty amazing that people watching TV would do exactly what you asked them to do. And it was fun. And we got to show more science on the air. It was awesome.
Yeah, that's really cool. So talk about your company real quick. Tell us what you do, because I think that's interesting.
Sure, thanks. So I left NBC in December of 2000 and started Storm Center Communications. In the first several years, 7-8 years, we developed environmental information websites for TV stations. But in 2008, I pivoted the company to focus on technology development. And what we've developed is a way to enable data sharing, geospatial data sharing, across any platform and across any mapping environment, any GIS system, so we can put people on the same map at the same time, so we can share data out in real time. That way we can help with situational awareness, help with decision making, and so now we're helping federal agencies do more with their data that they have. And so we're working with NOAA and the National Weather Service, working with NASA, FEMA and DHS have shown great interest in getting people onto the same platform, because it's not possible today unless you use something like screen sharing, Google Hangout or WebEx or GoToMeeting. That's the only way you can share information, but we actually deliver the data right into people's computers, even onto their cell phones, so their smartphones. So I can control the maps on everybody's cell phone and deliver data right to it in real time. It's pretty amazing, and I think it might impact television in the future.
Oh wow, that's a little foreshadowing of the future, huh? So Aubrey set this show up tonight. I know she's busy in her studio, and I'm perfectly glad to yield the floor to her if she can do it or whatever. But I thought tonight we would kind of come up with a process that she started here, and that would just be a no holds barred. You guys just immerse us in imagery and data, and talk to us about, how we can use these tools as operational forecasters to make a better forecast and a better warning. So I don't know who wants to start and how you want to run, because we really haven't rehearsed anything here. But
no, I think you said it best, Bill. I think that's, jump right in and show us. I mean, I was just oohing and ahhing. We don't get to see visually storms in the Shenandoah Valley. So even looking at Go 16 tonight, and I'm literally on a Facebook Live, like showing people, I'm like, all right, you see that puffy dot and you see how it fans out, it's just so overwhelming to us, and you just want to, spew your knowledge, and I want to learn more.
Yeah, I guess, Sheldon, if you don't mind, what I can do maybe is just start people off, generally speaking, with some of the...
Oops.
Oh, no.
Uh-oh.
Dave froze?
Dave is a frozen man.
It looks like
Yeah, very, very good look there, Dave. And let me just say this for those that are listening, and Sheldon, many of our people do listen. We're going to try and be as descriptive as possible.
Right.
So for those listening, you're not going to be left out. We are going to be showing some of this on the video version, but we're going to be very, very descriptive.
Very descriptive. Okay. Would you like to see what I've got?
Yes, we would, Sheldon.
Let's dive into this. Let's go.
Okay. All right. What I, as a satellite meteorologist, would do normally is just look at the big picture during the day. I wouldn't bother looking at the computer models to start my day because I don't want to be phased by what the models were forecasting for the day. So the big picture, this is polar orbiting microwave data, shows best the atmospheric total moisture, and it allows me to focus in on the areas of concern. Though that when I worked at Nestis, I was monitoring the weather for forecasters from Hawaii to Puerto Rico. So this is total atmospheric moisture from many different polar orbiting microwave satellites, and over the U.S. it's a combination of GOES sounder precipitable water and GPS precipitable water values.
Are you showing us that right now, Sheldon?
That's what I'm showing you right now.
Okay, so go ahead and screen share, because we can't see what you're showing us yet.
Oh.
So do your screen share.
No. Let's see.
Now we have two Daves.
Oh boy. Jeez.
Remember left side, green rectangle?
Oops. No.
I think I'm back.
Yeah, we are.
You're back. We thought you hung up on us, Dave.
Oh, okay.
Yeah.
Oh, okay. All right. I went to Google Hangout. Start screens. Okay. All right. Now let me get to my.
I get to see myself.
Oh, yeah.
Okay. Can you see me now?
Bingo.
Okay.
Yeah, looks good.
When I start analyzing, I look at the big picture because I would be looking at a whole large area where I would be monitoring the weather and giving my satellite expertise to all the forecasters across the country. And the two things that show up real well are the higher moisture with a front that comes into Virginia and then meets up with another area of higher moisture from the upper Ohio Valley down into the south. And then you see this long, extensive plume across the eastern Pacific that's going to give kind of an unusual wet period next day or so over the Pacific Northwest. So I would focus my area on areas of higher moisture and things like that. And then this is a percent of normal total precipitable water. It takes the total precipitable water and compares it with a climatology of precipitable water that was taken from a NASA experiment from 1988 to 1999. So that allows me to focus even more where the aqua colors, especially the darker aqua colors, are the higher precipitable water values, higher percent of normal values. The browns are very low below normal values. And you can see yellows are over 200%, and that's coming up across far northern California, the Northwest. So those big picture items, these products are products that will be in the JPSS era, and that JPSS launch, the next generation polar orbiter, will be coming up in later this year in September. So it allows me to focus in on the areas. This is another polar product that will be in the JPSS era. It shows moisture, total water moisture at 4 different layers of the atmosphere. And especially when you look at the 700 to 500, you can see a lot of various features in the moisture that can help forecasters both locate where maybe the heaviest rainfall will occur if the moisture is high and in many different layers, and also different features that like with GOES water vapor can produce heavy precipitation just by the instability that it causes. And the big features are, especially at the 700 500 millibar layer, is this frontal boundary that comes into Virginia and is in kind of nesting around Aubrey's area, and that's probably why she's been so busy this evening with the convective activity. So these are kind of features that you may not see with the geostationary data, because the microwave sensors see through the clouds. And even though GOES 16 is a great satellite and a great improvement over the previous generations of GOES satellites, you still, with the sensor, can't see through the clouds. So I try to emphasize to forecasters and anybody who will ever listen to me that we also need the polar orbiters, because the microwave data sees through the clouds. And maybe in 15 or 20 years with the next generation GOES, we'll have a microwave sensor on the geostationary, and we'll be able to be able to see through the clouds. So in focusing an area, this is the 5-minute data from earlier this afternoon or earlier this evening with this line of convection, which I'm sure James, you knew about as it was rolling through both northern and central Alabama. And what's interesting is convection that was bubbling up over southern Alabama was redeveloping further north and kind of merging with the convective activity. And this is the 5-minute data over a period of about 3 hours. And here's the infrared from GOES 16, being able to track the individual colder cloud tops. And you can kind of see they don't, in the 5-minute data, they don't kind of stay put. They're moving around and things like that. And so you have to kind of figure out where the various convective bands are going to kind of merge with other cells and drop its rain. And now, luckily, from the polar orbiting data, we only saw moderate moisture. So that, and with this line of storms that was moving pretty fast, you can tell that maybe there was some brief heavy rain, but I guess the biggest hazard with these storms would be severe weather, strong winds, severe thunderstorms, and kind of things like that. And then if you want to kind of get a sense, do an hour loop, like about 12, 13 frames to I guess focus in on the heaviest weather, the most hazardous weather. You can kind of do that with GOES 16. This with being the viz for only an hour. This is an hour loop. Whereas normally with GOES 13, you'd only have 3 or 4 pictures during the hour, because GOES 13 only gives you a picture every 15 minutes in normal mode. Whereas with normal mode with GOES 16, it's every 5 minutes. And in very severe cases where in mesoscale areas, we can go down to 1 minute imagery, and in experimental research mode, every 30 seconds. And here's how that looks. The shorter loop with the goes 16 IR for these thunderstorms, and you can see they're kind of scattered. There's a merger right over west central Alabama, and some cooling over southwest Alabama, but they don't really, stay over one spot for very long, as this as this frontal band or outflow boundary is kind of ripping southeastward through Alabama this evening. And then here's a kind of a GOES 16 water vapor image, which goes back to earlier this morning, and you can kind of follow the features. And the big difference between the GOES 16 water vapor is that it's 2 kilometers as opposed to 4 kilometers with the current GOES satellite. And as you can see, instead of getting an image every 15 or 30 minutes, you can get images every 5 or 10 minutes with the GOES water vapor imagery. But it's best to look at the water vapor imagery in the big CONUS view to see the more synoptic scale features. That's kind of how I interpret things during the day, and by trying to use a lot more than just the GOES 16 data, but other bigger picture moisture items from polar orbiters to allow me to focus better on the problem of the day.
So you said 2 kilometer on that water vapor. What about the resolution on the IR and the visible?
Okay, oops. Let me go back to the. Okay, with the visible, it's I believe a half mile. Half a kilometer as opposed to 1 kilometer with the GOES visible, and the IR I believe is 1 kilometer versus I guess 2 kilometers currently.
So you're actually able to nearly, or can you resolve actual cumulus clouds in a field?
Well, with the visible, it gets down to about 500 meters. So you're getting close. You're getting almost down to at least your neighborhood or a local area. And I think with maybe some techniques to put this maybe on Google Maps and things like that, I think it'd be very easy to in the future warn people on apps when the storms are kind of going through, and also let them know when the storms are going to be leaving. Pretty much kind of what we're doing now, but in a more personal way, and also a more graphical way. There's nothing like satellite data to kind of, especially satellite data with lots of colors to help explain to people where the storms are and when they're coming and when they're leaving, so to speak.
So Sheldon, on some of this stuff like today, I mean, you see so much motion even in the 5-minute data, but when you really look at 1-minute data, I mean, you start seeing features that probably you were only, theoretically thinking were there because you couldn't see them really in motion. And you see some crazy things. Talk about some of the things that it's opened your eyes to just in the few weeks or months you've had this data to look at.
Well, I think remember with GOES 13, you get a picture every 15 minutes. So 14 minutes is going by without seeing anything. So in that 14-minute period, things may come and go, and those are features that you don't see during that 14-minute period that could be resulting in severe weather, a flash flood, and that type of thing. So I think just the fact that you're getting information that to fill in those 10 or 15 minutes that you would normally not have from any other generation of geostationary imagery. That alone, is a step forward, a great step ahead, and I'm trying to look for a link that I have that may show the difference between the various channels. I'll have to try to figure that out at another time. But and another point that I should really make is that this imagery is available within 2 minutes of data time. Think back to when I was starting out in Nestis, and we had to wait 40 minutes just for a paper copy satellite picture. And now the imagery is in your workstation within 2 minutes of image time. I remember a fella that I used to work with who works as a contractor for the National Weather Service, and he was helping to make sure that there was enough bandwidth and that kind of space on the computer, because he knew that there was going to be a lot of satellite data, and the forecasters wanted the satellite data now. So that's what I've been really surprised about, being able to get the data to the user within 2 minutes of actual data time.
That's huge. Dave, I know you're sitting out there. We want to get you involved here too. Take a shot at a Western look right now at the visible satellite. There's so much going on just in the last dying light of day here that I'm amazed by, just in the 5-minute data. I don't know if you can pop something up like that, but take a shot at, what do you see there? And Sheldon, what are some things you see in just a live Western visible satellite loop right now?
Yeah, and let me, as Sheldon was talking about, I wanted to show you something else too before we go to anything live. So what I want to show is this is a satellite loop. Okay, scientists had an idea that they might be able to see ice with GOES 16, right? The movement of ice along the Greenland shores or down Newfoundland and Labrador. And I'm gonna play this loop to see what it. Hopefully you can see this, and I'll just let it keep running, where you can see the movement of ice. Can you see that? It's
Yes.
I'm not sure if it's full screen or not.
Yeah, actually you can.
Yeah, so it's just amazing of how many icebergs now that can be tracked using GOES 16, which is incredible.
They used to fly airplanes to check sea ice and things in the day, didn't they, Dave?
Oh, they still do it. The U.S. Coast Guard has responsibility for tracking and numbering icebergs that are coming off of Greenland and into the shipping lanes. And
so is this going to eventually be able to replace that sort of expensive operation?
I don't know if it'll be able to replace it, but it'll certainly give them a big picture of all of the threatening icebergs that are coming into shipping lanes, and then have the airplanes fly over. And look at that. You can see currents in some of these icebergs that are moving. It's quite dramatic, and it's pretty impressive. I wanted to show also there was a severe weather outbreak. You go forward here. There was severe weather outbreak, and before I do that, here's an example of GOES 16, the ABI sensor. And you were asking, Bill, I think you were asking, can you see cumulus fields in the IR? This is water vapor, and you can see mountain waves. These are mountain waves in Aubrey's area, right? The Shenandoah Valley, just out west of Washington, D.C., and you can now see it in water vapor. The image on the right is GOES 13 water vapor, so it's very difficult to see any sort of distinction.
Mm-hmm.
You kind of pick them out a little bit, but GOES 16 is going to give you so much more detail that people at SPC at where lands works and NSSL. They're all looking at this imagery and discovering something new just about every day.
Well, when you're looking at cloud top temperatures, like Sheldon was showing, it has to be much more valuable to have that temporal resolution as opposed to getting a 15-minute snapshot.
Oh yeah, absolutely. There's no question about that. And also what you'll be able to see as well is the water vapor channels in the current GOES. You just have one water vapor channel, right? In GOES 16, you have three water vapor channels where you'll now be able to look at high level moisture, mid-level moisture, and low level moisture. And so
really
that's
helpful in a severe weather situation.
Absolutely. It's really going to be of great benefit to severe weather situation. This is just an example real quick of that this year, the average number of icebergs to track for the Coast Guard, usually 150 to 200 icebergs. This year, they've been tracking more than 600 icebergs, not just because of GOES 16, but because there is an abundance of ice that's coming down in the northerly currents from Greenland and out of the Arctic.
So if they'd only had this for the Titanic, huh?
Oh my gosh! I mean, look at this. It's an example of a ship trying to make its way through, and that's not a good idea. So these are what the icebergs look like, in person off of Newfoundland, and it's quite amazing. GOES actually has more space weather sensors on it than Earth-looking sensors too. So we're constantly monitoring the sun as well with GOES 16, which is pretty amazing.
Now, what about sea surface temperatures?
Sea surface temperatures aren't a real. As a matter of fact, I have Sheldon. This might have been. I'm going to go backwards here just real quick.
Okay.
And show the different channels. There are 16 channels. In GOES, and so I'm gonna bring that up. There you go. Hopefully you can see that now. These are all the channels. I mean, they're going to be flowing into AWIPS, which is the Advanced Weather Interactive Processing System within the National Weather Service. All the forecast offices have been upgraded to AWIPS 2, and they're going to get continue upgrades so they can handle the flow of GOES data. As a matter of fact, there's so much GOES data that's coming down. They had to NOAA put direct readout ground stations for GOES at all of the national centers. So the Hurricane Center, the Storm Prediction Center, Climate Prediction Center, Weather Prediction Center, they all have their own GOES direct readout ground stations because AWIPS doesn't have the bandwidth to dispense all of that GOES data. But this is what you're going to see.
Go quickly over all those guys and tell us some of those channels that you're showing us on the screen there.
Sheldon, you want to talk to this at all, or?
Okay, well, again, let me just show you an example also of the difference between. Let's see. Let's screen share.
We'll let Bill Murray sing while Sheldon's getting that screen share going. Bill, go ahead and sing us a tune.
It concerns me that we're hurtling toward selling off this bandwidth, and is that going to be a problem down the road, Dave? If we, it seems to me like we're hurtling toward a real problem here, in getting all this data across, from the satellites to the Earth and wherever else we need to have it. If we sell off all this bandwidth, are you concerned about that?
Yeah, I am. You're talking about the spectrum auction, right? With interference that could happen. Absolutely. It's something that's not going to, disrupt every piece of weather information that flows. But when they auction off this spectrum, you're going to be competing with the direct broadcast from satellites like GOES 16. And so what that means is, folks at the Weather Service and EMC, they want to use more satellite data as initialization into the global models, right? And the global models are getting higher resolution. So it's really important to have good data into those global models. Once you start interfering because of that spectrum allocation interference you were talking about, Bill, you can start to contaminate some of that data. And if you contaminate that data, a couple things could happen, right? You could get bad data into the models. We don't want that. I mean, that's just about what every broadcast meteorologist is talking about. This model says this model says that. I wish they would use more of their meteorological skills to interpret those models. That's another discussion. But when you get into using contaminated data, the Weather Service is going to say, nope, we're throwing it out. And so all of a sudden, this data that's so precious, 95% of the data that goes in, that's used for model initialization, comes from satellites.
Wow.
95%. So we let off radiosondes, we have surface obs, we have all this stuff that goes into models, but 95% of it comes from satellites. That's how important satellites are. In a little bit, when Sheldon has that up and he talks a little, I'll show you a difference, just one difference. You may have seen this graphic. Lou Uccellini may have used it before, and some others. The difference in satellite data from the placement of Hurricane Sandy. If you use satellite data to initialize the model versus if you don't have satellite data, what the difference in that forecast is. So,
wow. So Sheldon, you got your screen sharing ready over there?
You don't see anything yet?
We see you.
Okay, let me. I'm doing the Mozilla. Oh, I'm sorry. Okay.
There you go.
Let's see.
It's coming. There's me.
Okay, there we go.
Switch tabs. There you go.
There's a great example of the difference between GOES 13, every 15-minute data, and super duper rapid scan and GOES 16 every 1 minute data. There it is. So, look at all the information that you're missing during that time that you're waiting 15 minutes for that satellite image from GOES 13. You could have a tornado on the ground. It could destroy a town. It could destroy people in the time that you get in the time that you get another satellite image from a regular satellite image from GOES 13. So that quite clearly shows the usefulness of, in this case, 30-second data, and many times in hazardous areas, 1 minute data compared with the normal 15-minute data from GOES 13.
So it seems to me like that, overshooting tops were sort of a rather rare occurrence and fairly unique, but it seems to me like we're learning in the past few weeks that they're really more common than we thought. Is that a true or false statement, guys?
No, they're always around. It's just that you can see them better now, and you can really see them better, especially in this loop. That there's some really intense stuff going on underneath this thunderstorm, and even the little one that's up across the far northern part of the Texas Panhandle that's kind of getting obscured a little toward the end of the loop by the cirrus from the outflow from the storm further south in the central and southern Texas Panhandle. Another Viz loop, and you can kind of see the wiggleness that goes on, especially when you see the data every 5 minutes. You're going to see a lot more than you saw with the 15-minute data, and that's kind of a learning situation. Every forecaster in their particular area is going to have to learn and understand this data maybe all over again, because now looking at 5-minute data as opposed to 15-minute data, you see a lot more things that can help you get a handle on the hazardous situation that's to come for a number of communities. Some more viz, and in this case, you can see the incredible amount of moisture that's coming southeast to northwest from probably the Gulf of Mexico that's feeding these storms. And this is actually a different type of imagery where they overlay the IR on the the visible, and it's what we call kind of a sandwich product. It's there are two different channels sandwiched between each other, and you can it kind of gives you a 2 or 3 dimensional look to the thunderstorm that in this case develops over southwest Oklahoma. Then here's a possibility where warnings can be developed off of both satellite and radar. And in this case, the warnings that come out are overlaid on the actual satellite viz data that and the 5-minute data for these storms that are moving across Colorado. Here's another instance where you can conceivably warn both on radar and satellite because now satellite competes rather well both with the timeliness and how often you get the information and kind of see the kind of the dry line slamming with these short wave that comes out of New Mexico and really flares things up with that connection. And here's another instance where kind of the visible at the top and the IR at the bottom so that you can kind of look at the cold cloud tops and what it looks like on the visible as the storms go by. That kind of it allows you to learn more about the data as well. Again, this is a weather situation back in May in Wisconsin. You can kind of very easily follow the storms with this 5-minute data, whereas there would be a lot of things missing if you're only looking at 15-minute data. And I do know that when I used to do satellite rainfall estimates, we would originally started doing the estimates with every 30-minute data, and then with every 15-minute data, it became too difficult, and they automated the satellite-derived rain estimates. And now that we have 5-minute data, you can conceivably do satellite rainfall estimates every 5 minutes, and that's now also being incorporated into the great rainfall map that's being created as a National Weather Service initiative to merge and blend both satellite and radar and observational data into a unified rain product.
So, Dave, you were showing some of those. You're showing 16 channels, I think, a second ago. Can you share some of those that are going to be interesting to us as operational meteorologists?
Yep.
Yeah, the channels, what I had brought up just a second ago, and I'm going to do a quick screen share as well, is the difference that satellites make in numerical weather prediction. So this particular graphic shows on the left is ECMWF forecast with satellite data used as its initialization. This is the position of Sandy at the same time without satellite data. So you can see the big difference in the positioning of the storm and the intensity of the storm when you don't have satellite information. It's critical.
So you're seeing a difference of about 250, 300 miles in the actual and the forecast positions, or I guess that's two forecast positions. The actual on the left is really closer to where the center of the hurricane, or what was Hurricane Sandy ended up, huh?
Exactly. And then in the right, without satellite data to initialize the model, Sandy never made landfall.
Yeah, that's interesting.
So it just shows you just how critical it is. The assimilation systems that are put together to take all that data in are just really desperately need that satellite data. And GOES today, the GOES satellite data today, a lot of that data falls on the floor because they're not assimilating GOES data. They're using a lot of polar orbiting data. They're not using a lot of GOES data. And so now with GOES-R and GOES 16, they will be assimilating more and more of that data into the numerical weather prediction models. So just as you use GOES data for observing the updates in the imagery and what's happening with that squall line, what's happening with that severe weather, what's happening to the marine layer, what's happening to wildfires, what's happening to the icebergs or ice movement, you're going to see more and more observations. So that's really going to be helping to kick those models in line. For example, when we run the rapid refresh, model, as that in the future uses more GOES data, you're going to get more accurate model data spit out, right? So you'll be able to, like Lance, talks about a lot with his facets project, warn on forecast. GOES data will ultimately become critical to producing accurate warn on forecast output, right? So all of this data that really comes together is not only fascinating, but it's critical. And the different channels, for example, let me pull up here the channel one. Here's this is an example of all the different satellites that are orbiting both NOAA and NASA that are collecting polar orbiting data. That some are from the Europeans, some are from NASA, which are research missions, and the ones that you see that are DMSP and NOAA all collect operational satellite data. So that's pretty wild. Let me go forward with the.
And also, but may I say, more than at any other time in satellite history, are we using research type of satellites for imagery and observations, and including in our operational satellite products. So I think finally people are recognizing the fact that we have to also use our research satellites and incorporate it into the operational blended total civil water product, layered civil water product to help fill in the imagery, so that like the polar microwave products can look a little bit more like geostationary satellite data.
So Dave, when I see true color, what does that really mean?
True color imagery gives you the data that show you. Well, for example, I'll screen share this particular image that I have up now, which is down in the southern hemisphere. This particular image is a tropical cyclone that's that was hitting Australia a month or so ago. And when you talk about true color imagery, you're talking about red, green, and blue. There is not a green channel on GOES 16, but they can simulate it very easily by combining different channels. But you can see the vegetation. Look at the health of the vegetation. Think about how this is going to transform the weathercast on television. Help Aubrey with flood forecasting when she can look at the vegetation in the Shenandoah Valley, or you can look at deserts, or you can look at what's going on, and then see something like this monster heading toward you, whether it's severe weather or whether it's a hurricane or a typhoon. You'll be able to see the impacts on the land that weather is making, and this extreme weather is making. You'll be able to go through seasonal cycles of satellite imagery to show whether or not your area is greening up faster. Are the pollen counts higher? Why are they higher? Well, because of these temperatures that are coming up. Even the USDA recently redrew.
Oops.
I think Dave was going to say they recently redrew the zone maps. I just looked at mine, and here in Alabama, it's changed over the decades to what plant zone plants are hardy here. I think that's interesting.
Bill, I could show you a loop if I can screen share if you want.
I'm just going to turn that. turn that off there. So I don't know if you can see me or not. It looks like it's shifting back and forth. But in the when you're talking about true color images, you're now getting a picture of how the land is changing with the weather and the climate. And you can see coastal zones. You can see how flooding rains are causing sediment to wash out into the ocean, to impact beaches, to cause harmful algal blooms. You know, the majority of the farmland in the middle part of the country, they fertilize their fields. It rains hard. That fertilizer runs into the rivers, into the streams, right into the Mississippi, down the Mississippi, and creates that dead zone. And that dead zone in the Gulf of Mexico is expanding, right? It's getting bigger, it's contracting, gets bigger, it contracts based on how much fertilizer the middle part of the country puts in there. And we'll be able to monitor that with GOES. And we'll be able to supplement that data with POES. So the polar orbiting satellite imagery and data that's acquired, that's even higher resolution than GOES, can really start to show you communities that are flooded. You know, I mean, after Hurricane Matthew made the landfall in the Carolinas, boy, a lot of people evacuated away from the coastline, and all of a sudden what happened was where they evacuated to got flooded. And you can see that appearing in satellite imagery. And so these are the type, as the resolution gets higher and higher, these are the type of things that we'll be able to monitor with land use and land planning and all the impacts that weather's having on it. But that's kind of true color imagery. Long answer, but you can do a lot with true color imagery.
Yeah, talk about fog for a second, because it's sometimes as a forecaster you're relatively blind unless you're knowledgeable in all those different channels, and I'm sure a lot of the newer channels are going to help us even more determine the difference between fog and stratus and et cetera, et cetera. That's got to be a big help for aviation.
Oh yeah, big time. Especially San Francisco, right? They're the most delayed airport in the nation because of fog and low stratus. And I have an image. Let me share this one right here. This is from the night light sensor on JPSS, the Joint Polar Satellite System. This is SNPP, the SUMI NPOS Preparatory Project Satellite. Look at all the stuff that's going on here. You can see the low-level stratus from cold air coming across the land off the mid-Atlantic. You can see the night lights. So we can see night lights every night from polar orbiting satellites. And snow cover. This is the snow cover. What you're seeing is illumination of the snow from lights underneath. I mean, the lights lighting up the snow, and then perhaps we have a full moon or a half moon, crescent moon that's being reflected back out, and the sensor's picking that up. You can see the high cirrus clouds over towards Minnesota and Iowa, and then the snow already on the ground. So think about using weather satellites now to monitor power outages, right? You have severe weather that goes through, you'll be able to see power outages if they're a large enough scale in polar orbiting satellite imagery for response and damage assessment and all that sort of stuff. But, Bill, just like you were saying with fog, you can monitor that now at night. Low-level fog at night with polar orbiting satellite imagery, and even GOES 16 with some of the channel differences. And since you have 16 channels, you can do all sorts of things with those channels. You can subtract them. You can add them together. You can let's say like subtract them or difference them to really show exactly what's going on with low-level moisture versus mid-level moisture and all that sort of stuff. Look for a fog image. Sheldon, I don't know if you want to talk about it. You have any image examples of fog there?
I think we've lost Sheldon. He's disappeared from our radar.
Oh no.
David, we're all concerned about the hurricane season. There's signs that increasing signs it's going to be a very active season. What are some tools that the satellite's going to give us as forecasters to do a better job in plotting the future courses of these storms?
Yeah, that's a great question. I mean, certainly the seasonal forecasts are out there, and gives us an above average likelihood of storms. I'm going to go ahead and share my. I'll drag this over here and share my screen with some of the latest sea surface temperature data. This is using Storm Center's tool called GeoCollaborate. And this is pulling in the latest sea surface temperature data from the polar orbiting satellites. So we can take a look. The Gulf of Mexico, as you guys know, is way abnormally warm right now. I mean, it's way up there. You can see the. I can maybe go in and get some other. Let me see some domestic satellite imagery of. There's some more sea surface temperature data. See if that comes on as well. These white areas you see are clouds that obstruct the sea surface temperatures. But certainly we have above average temperatures for the Atlantic and the Gulf of Mexico and the Caribbean. So that energy is there. You really need the synoptic situation to set up to get those storms spinning and moving into this warm water. But it looks like with the outlook and no real La Nina or El Nino, then there'll be a good chance for low shear in that environment where the storms are forming. And if that's the case, then we'll see a number of these potential seedlings developing into tropical systems. And I'll tell you, if there's weak shear in the Gulf of Mexico or any storm gets into that area, there's going to be cause for a lot of concern.
Well, and even interesting to me, I mean, you've looked at sea surface maps for a long time, but with this sort of resolution, you're going to see much smaller scale warm eddies like the one that allowed Hurricane Katrina to intensify so rapidly.
Oh, yeah.
That's got to be a huge boon in terms of intensity forecasting.
Well, it certainly will, and it's interesting when you see those storms move over those warm eddies, and if the right atmospheric conditions are there, that can really fuel the storm even more. And I think what you'll see as these satellites start to bring in more high-resolution data, you'll see people like James, right, on TV talking about, look at this patch of really warm water in the Gulf of Mexico. Or, anybody from Miami up to Boston talking about the warm water off the East Coast and how the Gulf Stream is really pumping up a lot of warm water. So if you have above average water in the Gulf and in the Caribbean, guess what? It gets caught right up in that conveyor belt going right up the coast, and you have lots of potential energy there to fuel storms that might otherwise get weakened. And the other problem is that when you have above average sea surface temperatures like this that you can see in the satellite records, storms that move slowly tend to upwell cooler water that can tend to weaken them if they move slower. But what we're seeing is that the sea surface, the depth of the anomaly, the anomalous warm water is deeper. And so it means it takes longer for the storm to upwell cooler water. So it doesn't necessarily mean that a lot of cool water will be upwelled when the storms, even if they move a little slower. So I personally, it's going to be a very interesting season to watch, and something that I can zoom out here and sort of look at the overall. There are all sorts of data layers that we can get access to through our GeoCollaborate capability, and some are model data. Some is real satellite data, and when you look at the real satellite stuff, it looks kind of noisy, but you can really dive in here, let's just say off the Maryland, Delaware, Virginia coastline, and dive in and look at these sea surface temperatures, and as you get closer, it resolves, and it's quite amazing when you see just the overall warmth. Now, I'm actually live in Bethany Beach, Delaware right now, and the sea surface temperatures are about 68 degrees. So it's that's right here, but you don't have to go too far off the coast to hit the Gulf Stream where it gets, quite warm. But right along the coast.
Dave, these are verified with the buoy network pretty well, I guess, or no?
Oh yeah, as a matter of fact, I can go and get buoy data live here through the marine obs.
And that's actual temperature, right? Not anomalies.
Yeah, these are sea surface temperatures. Mm-hmm. So if I go
you
in
can pick where to go to the beach, Aubrey.
Wow, awesome. I'm so amazed at that level of detail. I mean, it's just.
Yeah, it's very cool. Now I can zoom in here, and we're seeing now live buoy data. So if I click on a buoy ob here, this is Army Corps of Engineer observation. You can see that pops up. It gives the wave period. It doesn't give the sea surface temperatures here, but we can go in and click on any one of these. Here's a water temperature of 70 degrees at Lewis Station, right in the northern part of Delaware. So this is all
headed this weekend.
Yeah, it's nice. 70 is still a little bit chilly though. But
come on down here, Aubrey, where it's 85 in the
beautification.
So how effective and useful would this be? We've got a landfalling or land approaching hurricane, and the coastline is under the CDO, but you're looking for some sort of last minute warming or intensification or weakening due to surface temperature before it comes in. Is that going to be helpful, or is it not going to cut through that cloud cover? What's going to happen there?
Well, I mean, what you do is, if you really want to look at the raw sea surface temperature data, you access the polar orbiting imagery, and you can see what we're looking at right here live. And so if you want to get a smooth, so what the satellites do is they keep, passing over polar orbiting orbits, taking strips of data. You can smooth that out and get rid of the clouds. And you can also put it into models that give you a much higher, it gives you a high resolution look at the sea surface temperatures over a 3, 4, 5 day period without any clouds. And then you see everything that's there without the clouds. So there are a number of sea surface temperature type data that you can look at, and it's all available from NOAA. I mean, this is what we're pulling in web services right now. So anybody who stands up web services like GIS data, we can pull in from any source. We could merge Homeland Security data on here. We could merge critical infrastructure data on here. We could merge NOAA data, NASA data, ship data. Look, in these observations, look, there's a ship right here, right off the coast of Georgia. And they're giving an air temperature of 81 and a water temperature of 80.8 degrees. This is through the volunteer network that the ships participate in. They don't give the name of the ship because they don't want, to give out a particular ship and where it's located, but they are sharing the weather data. And sometimes you find these ships awful darn close to tropical systems.
And I'm sorry, I've been off doing a show. The stuff you're showing, this is available to the public, or this is not yet?
The data is available to the public. What we're showing, what I'm using right now is technology that Storm Center that we've developed that can share this data out in real time to systems all over the world, whether it's a mobile device, whether it's a tablet, whether it's a laptop. And we're right now doing this work within federal agencies. So we're helping NOAA and the Weather Service come up with ideas on how they can supply impact-based decision support services to emergency managers, how emergency managers can use it to communicate to their constituents on where to evacuate. But I think it probably won't be too far out in the future where this technology, GeoCollaborate, is available for media use. We haven't released it for that yet because we're still going through testing, but it's very cool actually. We developed it under a program called the Small Business Innovation Research Program within the federal government, and because we've been working in it for 6 years, we've been down selected to sole source status with every federal agency in the U.S. government, so they can immediately apply this technology in their decision-making environments.
And I know James will want to know when it will be available for social media posting.
Oh,
Yeah. Yeah, no, it's great. Actually, if you just, you guys are all visionaries here. Just imagine being able to connect with your viewers and controlling the map and the data that displays on their mobile devices in real time. Or controlling their map as they're watching you live on television and they're receiving the data that you're displaying on TV in real time. It's a whole new way that you can connect with your viewers. Just something we haven't gone down that alley yet, but it's certainly in our vision category, if you will.
So Dave, we hear a lot about the lightning mapper. Tell us about that. How does it work, and
How
what
do we get
data will it
access to
have?
it?
Yeah, well, that's a great question. GLM is a sensor that is basically revolutionizing lightning observation. Here's the thing about GLM is that the data rates are so fast. They're still trying to figure out how they can get those data rates and turned around and delivered into somebody like a TV station through a weather vendor. There's also calibration and validation going on. You have WeatherBug and Earth Networks, or those guys that have that ground-based lightning network. NOAA's actually buying their data so they can use it to calibrate and validate GLM. So it's phenomenal, the video feed that you can see of GLM when you just look at 1 minute data and you can see the flashes going on. That's phenomenal. I think it's going to be more like a video feed initially, then it will step over into a data feed. But I think it's a really good question that you could ask your weather vendors out there, especially when you're in Kansas City. I'll be out in Kansas City as well. I'm giving a presentation actually on GeoCollaborate and delivering data via GeoCollaborate. But GLM is a very new animal. I think it's going to be quite helpful, but actually getting it into systems so you can see it, I think you might be using it as a produced movie loop that you can bring into your weather system to show and just say, wow, look at all these lightning strikes from the new GOES satellite. Let's go to our lightning detection network to show you where the cloud to ground lightning is going on.
And so is it differentiating between cloud to ground and in cloud? And are you getting latitude, longitude from the CGs too?
You're seeing, it's basically the GLM is an optical sensor.
Just a movie.
It's what you would see if you were up in the space shuttle orbiting the Earth and you saw lightning flashes going on. So it doesn't distinguish between cloud to ground and cloud to cloud. But what they're finding is simply incredible. For example, a cloud to cloud lightning, when you see the finger lightning in severe storms, or you see it, going across the sky in the cloud. Some of those lightning bolts, they're finding out, go for hundreds and hundreds of miles. It's not just in that one thunderstorm. It can extend all the way over 200 and 300 miles. And this is the kind of research that they're finding out right now, which is just, it's fabulous. But what it also tells you is there are a lot more bolts from the blue that are happening. Lightning is extending out beyond the thunderstorm in many more occasions than we see some, rare pictures. So that should extend to your messages on the air. When you have thunderstorms around anywhere, you shouldn't be outside because, kids on the ball field could be struck when a storm is 10, 15 miles away. Oh. And so I think that's going to also revolutionize how you communicate on the air when you need to seek shelter, because you may not hear that thunder, right? That proverbial heat lightning, right? Where the lightning strikes and
just
you don't
spell
hear
it right. That's all
lightning.
Heat lightning.
Dave,
it'll be very enlightening. Right?
Dave, I have a PowerPoint slide of that. If I guess I can try to screen save or a screen share.
Sure.
Do it, Shelley.
Okay.
We need to get while he's doing that, we need to get this lightning data to SPC so that we can then combine it with the number of people impacted or potentially impacted like they do.
Oh, brother.
So that Al
80
Roker,
million
right,
people in the path.
right? Al Roker can use that on NBC.
Some of our severe thunderstorms.
It might be easier to say who's not in the path.
Right.
Here's an example of the full disk with some lightning on it. What's very interesting is there's a huge amount of more lightning over land than over the ocean, which I was kind of floored about.
Sheldon, we're actually seeing Dave as opposed to, I think, what you're trying to show us.
Oh, shoot.
Yeah.
Well, we like Dave, but
Well, Dave's a very attractive
Double
man, but that's
Dave.
not quite the object of the game.
Exactly.
Let me try to screen.
Just change tabs up there. Pick a tab, any tab.
show title.
Yep, that is the show title.
Oh, any tab. Oh, wait a minute. Okay. Nope, I can't. Shoot. Yep, I guess. Oh, I guess I can't.
The higher the IQ of our guest, the harder it is to figure out Google Hangouts. We've learned that.
Yeah, that's right. So you can't see that.
We're
it's
seeing
an image-
pitch black. There's nothing home.
It's an image of
The
Southeast.
North Korea lightning or light.
Yeah, North Korea at night.
At high resolution.
Exclusive view on WeatherBrains.
Show title.
Yeah.
Okay. Well,
This certifies that Shelton's IQ is over 300. Hey, I tell you, well, while you're doing that, let me roll Brian Peters' segment here, Sheldon. So we're going to roll Brian's Professor Peters WeatherBrains 101. We'll come back with more GOES 16 information. We'll do picks of the week and much more as WeatherBrains rolls along.
WeatherBrains 101 with Professor Peters.
GOES 16, the most advanced weather satellite ever developed by NOAA, will be moved to the GOES East position at 75 degrees west longitude once it becomes operational in November. GOES 16 brings a new level of detail in observations and other data that will mean improvements in forecasts, provide considerable benefits to the economy, and help improve public safety. Situational awareness from this detailed view from space should lead to more accurate, timely, and reliable watches and warnings. GOES 16, launched on November the 19th, 2016, continued to undergo an extensive engineering checkout and instrument validation period. But once GOES 16 reaches its easternmost location, the current GOES East satellite, GOES 13, will be placed into orbital storage along with GOES 14 and remain available if needed. This perch for GOES 16 will provide a view of the entire continental U.S. and monitor areas vulnerable to tornadoes, floods, landfalling tropical storms, hurricanes, and other severe storms. Capabilities of GOES 16 are amazing. It can scan the Earth 5 times faster than current geostationary weather satellites, sending sharper, more defined images at 4 times greater resolution as often as every 30 seconds. The higher resolution will bring forecasters more detail in storm systems, especially during periods of rapid strengthening or weakening. GOES 16 also carries the first lightning detector flown in geostationary orbit. Total lightning data encompassing in-cloud and cloud-to-ground lightning from the lightning mapper will provide critical information to forecasters, allowing them to focus on developing severe storms much earlier. GOES 15 will continue as the GOES West satellite, positioning satellites in the east and west locations along with an on-orbit spare ensures that forecasters get a thorough look at developing weather systems that affect the U.S. all the way from the western Pacific to the coast of Africa. More like GOES 16 will be coming. The next GOES S is scheduled to launch by spring 2018, followed by the launches of GOES T and GOES U in 2020 and 2024, respectively. If you have a question concerning the weather, drop an email to question@weatherbrains.com.
When the weather ball is red, warmer weather is ahead. When the weather ball is white, colder weather is in sight. When the weather ball is green, no change in the weather is foreseen. When colors blink by night or day, precipitation's on the way.
This show is for June the 19th, and we're not going to do a big weather roundup here because we're recording the show on June 15th, but this is the image that all the social meteorologists are sharing, guys. This is the this is the Canadian, okay? So you know what they're going to do? They're going to find some outlier,
Really, the Canadian? Come on.
crappy tropical output, and a major Category 5 hurricane is headed for the Florida Panhandle next week. So this is what they're on, and of course, the truth in that is probably close to zero. But there is a chance. I do think there'll be a tropical system in the southwestern Gulf when you listen to this. The question is, at this point, we don't know if it develops or where it goes. But just something to watch, and 'tis the season for that. But again, since we're not that good, we can't do a weather roundup for 5 or 6 days in advance. So, Bill, I'll let you pick it back up with our guest here, and I've got to go do some television here. I do have to get dressed, and I'm the lead tonight. So, Bill, I'll let you take it away, and you do picks of the week and email and whatever else.
All the audio are going, James is doing this naked?
James in the nude. That's a show title.
Oh, that's funny. So Aubrey, while we got you, do we need to do some email?
We can do some email. I was just going to say.
Wait, I can play your jingle here. Hang on. I've always got time. I've always got time to play that email jingle just for Aubrey.
Letters. We get letters. We get stacks and stacks of letters.
I was going to yield more time to Sheldon if he had more things for email, because I don't think we have a whole lot, but we will.
The only thing I have to show is the lightning mapper example.
Okay, well, we'll come back to that in just a second. Let's let Aubrey.
Okay, that's
all
fine.
right. I'll do.
We could go all night. We could go all night.
Okay.
Daniel Lucas sent us an image. It was from the Capital Weather Gang. More than 700 young children have died in hot cars since 1998. Oh. Let's see. Representative Tim Ryan, Democrat in Ohio, wants to put an end to these traumas. And, I've seen some really good images that us as broadcast meteorologists can really put out on air instead of saying, hey, your car, gets up to 100 degrees in like 10 to 15 minutes. But if we can make and detail a little bit more of these graphics that National Weather Service and NOAA puts out with the timing and go through, I think that really would help people really sink more into it. It's like, you can tell someone the temperature of the day, but you need to describe the day if you really want to get that information through. Now,
Aubrey, talk about that for a second, because I'm not familiar. I haven't read the article, and maybe they shared it on the Capital Weather Gang. But what is this technology that they say is so cheaply automakers will be able to integrate into their vehicles right away? That's going to protect kids, because I think that was at issue in the excerpt that I read. Does anybody know what this is? Is it a sonic technology, or what lets the car know that there's been a child?
I would assume it's something kind of similar to the drunk driving, the breathalyzer that you have to use to turn on the car. Maybe some sort of technology along that line, but I haven't heard of the actual. I'm scanning through.
Yeah, that would be very interesting to me, because if that technology were automatically available.
It's a bill that this is talking about, but it doesn't go into detail about any sort of technology.
Yeah, it's going to be interesting to explore that a little bit, because I think it says in there that the technology is already available and can be spread over the industry and would be negligible what the cost would be.
Technology already exists, and that General Motors has applied it in many of their 2017 and 2018 model. Okay, here it is. Transportation Department would require cars to come equipped with a system for alerting the driver if a child is left in the back seat after the car is turned off.
It'd be a weight sensor then.
That's what I was thinking. How do you know it's not heavy groceries, though? You know what I mean?
Yeah, well, that's a step. I mean, we had an incident here last fall when it was so warm, but it was not an exceptionally hot day. Mm-hmm. And a father went into work, left the child in the car for not a very long period of time. And fortunately, somebody else saw the child, and it ended up with heat exhaustion or whatever, but didn't pass away, luckily. But, a tragedy was only averted narrowly, because this car was literally sitting in dappled sunshine, not in bright full sunshine, in sort of a shady parking lot. And you just really have to think. And those situations are just so
I
hard.
know.
So glad you
we
shared
wanna
that, Aubrey.
we want to prevent more of those. So next email, Sonora Meadows, listener survey response. Typically listen via the iPhone when driving or the laptop. The longer the better. I enjoy every minute of it and appreciate you guys so much. I always learn something new as an enthusiast meteorology student, currently a student, 3 years weather internship for an Oklahoma TV station, storm chaser, and long life weather enthusiast from Tulsa, Oklahoma. I would love more advice of any kind from meteorology students, people trying to pursue this field. I would love more personal stories of past weather events, particularly tornadoes when possible. And I know, Bill, you always do a lot with that weather history. I enjoy some weather history too. So
yeah, we need to get back into more of that. I need to start
yeah,
doing a little bit more of that again.
And the Jonathan Thompson sent us in a picture on Tuesday after our last Monday show when this is airing. Span's hashtag for June 22nd meeting should be hashtag widespread panic. So you can send your emails to email@weatherbrains.com. Guest suggestion show topics you want to talk about. We definitely love those. Sometimes we run out of ideas and we want to hear what you guys want to hear from us. So we like that. email@weatherbrains.com.
That's great. Thank you, Aubrey, for sharing that. So Sheldon, you were gonna bring us up today. You were gonna show us an example of what the lightning mapper may look like. And then I want to ask you a question relating to that.
Okay, can you?
Yes, we can. That looks perfect.
Can you
Yes.
see that? That's what a global image of lightning looks like. And here is what hopefully, as you can see, the time rolling in the bottom from February 14th of this year. What hopefully we'll be getting out of the lightning. I'm not exactly sure how it will look, whether it will look like this, but this kind of gives you an example of the of how the flashes will kind of look from the lightning mapper. And the incredible thing is that many times lightning is a precursor of severe weather or even heavy rain and flash flooding. So it's another tool in the meteorologist's toolkit to help us get an early start on the possible hazardous weather that is coming your way.
Now, somewhere I saw what may be a prototype graphic or a pro forma type graphic of what it's going to look like, but it showed graphically flash rates in terms of, greens to reds or something like that. Is that something we might see as a tool out of the lightning mapper?
That I'm not sure, but because I know there's a Steve Goodman who is pretty much the father of the lightning mapper for GOES. He would be an excellent person to ask that question because he knows just about everything about the GOES lightning mapper that is about to be looked at, rolled out in the next couple weeks for people to look at. Since it is an experimental product that has never flown on a geostationary image satellite, it takes a little while, a little research to kind of fine tune it so that it's ready for people to look at.
Anything to add to that, Dave?
Well, no, I think it's going to be tremendous contributor, and I think we're going to see some really cool things from GOES 16.2 coming up very soon, and that is in August. We have this eclipse coming, which is going to be the a total solar eclipse. And I actually, this is my very first time on WeatherBrains, but I do have an announcement I'd like to make.
Oh, we're missing our producer who could give us the breaking news music. So just pretend you're hearing the breaking news jingle right now.
Okay, pretend we're hearing breaking news. So this is what we're going to be doing. As a matter of fact, we just found out officially today. I've been sort of teasing this on Facebook because I have a group that I've created, which is the group is called Eclipse 2017 for TV meteorologists. So if anybody can find that group on Facebook request to join, and then I'll be putting out all sorts of announcements starting tomorrow. But what I can say here, and I'm going to share my screen, is that we're getting funding from NASA. And this funding is going to allow us to do a lot of neat things. Number one, we're going to produce content and gather interviews and sound bites from scientists at NASA about the impacts of the eclipse. It's going to be, coming from Oregon all the way across the country to South Carolina. Now listen to this. This is amazing because most people think when they hear about the eclipse, it's 2 minutes or 2.5 minutes of darkness that's going to be the spectacular thing. It's a 70-mile wide band where the path of totality is going to be. But here's the thing. 200 million people live within a 1 day's drive of the path of totality. 200 million.
The biggest
people.
traffic jam in American history.
You got it. It's states are very concerned about people visiting to see the eclipse. For example, Columbia, South Carolina. We're working closely with Jim Gandy down there, chief meteorologist at WLTX. They have a population of about 140,000 people in Columbia, South Carolina. They're expecting 1.2 million people. 1.2 million. And so the Department of Transportation is thinking, well, people are going to stagger their arrival into the South Carolina area by going 3 days ahead of time, maybe 2, whatever. So they don't think there's going to be a terrible traffic jam leading up to the eclipse, except when the eclipse happens. So this is something for all the broadcast meteorologists out there, and something that I'll talk about a little bit in Kansas City, is that people will stop on the road when they see the eclipse. When it gets dark, they're going to stop on the highway, and they're going to get out of their car, and they're going to look up, and a lot of people aren't going to stop on the highway. And so there are some states that are thinking that they might close the highways across the path of totality across the state. That'll create hours and hours of backups. So, and also don't try to rent a spot-a-pot anywhere in the country that week, because they're all rented.
A what thing?
They're a spot-a-pot, a porta-john, something that you...
A porta-potty, huh? Yeah, okay.
Yeah, a porta-potty that you set up in, there's one town that has hired Ozzy Osbourne to sing during the eclipse, and when the totality hits,
oh God,
he's going to sing "Bark at the Moon." So, the nation is going to go crazy with this eclipse, and broadcast meteorologists are critical in communicating this because a lot of their viewers are going to want to drive there. And we're going to get GOES 16 data, and we're going to put it out live through the GeoCollaborate dashboard to broadcast meteorologists, so you can watch the shadow move across the country. So it's going to be pretty darn cool that you'll be able to show that on the air. Plus, we're going to have a satellite truck. And we're going to take that satellite truck to Madras, Oregon. We're going to be at Madras High School with a satellite truck broadcasting the eclipse live for every TV station to pick up that signal and see it. NASA's going to have 9 other locations across the path of totality, and you'll be able to pick that as well for live shots. And the other cool thing is they're going to be flying an airplane in the Pacific Northwest during totality, and they're going to be launching several balloons up to 100,000 feet with live video, and that video is going to be streamed. So there's all sorts of opportunities, but the cool thing is this is really going to be the interface between space weather and our weather. Because when the path of totality crosses over certain areas, the temperature is going to go down, it's going to get dark, animal behavior is going to change. There's, put a camera at the zoo, watch what the animals do. It's going to be phenomenal. So it's really going to engage people.
And Dave and Bill, I've experienced with the eclipse in 1970, March of 1970 in Philadelphia, and it was an eerie sight, early afternoon. The almost total eclipse in Philadelphia, where I was living at the time. The birds stopped chirping. The sky got dark, almost twilight, or close to darkness. And I do remember the temperature cooling off in the middle of the day. So it will feel strange for those for that time when there is the eclipse over those parts of the U.S.
So that's August 21st. It's not that far away now. I can't believe it.
That's right. August 21st. And we're actually, Bill, we're going to be announcing on that Facebook page a webinar that we're going to do live from NASA Goddard Space Flight Center. And it's going to have a NASA scientist. It's going to have a Department of Transportation official. And we already have a recording from the Missouri Department of Transportation, because, you know, it basically goes through St. Louis. They're going to pull up every construction cone, you know, try to open up every lane and all that sort of stuff. So it's going to be pretty wild.
Yeah, that's just going to be crazy. A couple things I wanted to talk about before we let you guys get away. One of those is using the data to help spot incipient or just developing fires. Is that channel already there? Which channel do we look at? You know, is it going to be available to us in real time?
Yeah, you'll, first of all, Sheldon, if you don't mind, I'll just go first for the first minute here. The visible channel is awesome for spotting wildfires. We've done it already. And the 1 minute data, or even the 5 minute data, it really can pick up the smoke plumes and you can see what's going on. So that's
so
amazing.
You're using visible there to follow a smoke plume.
Yes, yes. And the polar orbiting data has infrared sensors on it that can identify hotspots, right? So if you have a lightning strike and you have a fire that's starting, once it gets to a certain size, even less than a kilometer, then hotspots start to show up on the satellite. And then you start to see the smoke. And this is very evident, particularly with polar orbiting data up in Alaska, because they have such wilderness up there. You can see that forming. But we've seen many wildfires in GOES data. As a matter of fact, I'm going to try to look real quickly here to see if I have any of that data. Yeah, it doesn't look like it. We can have, you know, show examples and perhaps another. You have one?
I have a example from the difference between GOES 13 and GOES 16. I'll try to screen save that if I can put that up. I'm trying to find my Mozilla window.
You got too many tabs open, or too many applications open, Sheldon.
Okay. Let me close a few while we.
You know, while Sheldon's doing that, I'll just mention that the folks in Alaska are dependent very heavily on satellite data to find wildfires, and they're also starting to fly drones where they think that wildfire hotspots might be showing up in satellite data. Then they can launch drones to see if they can image those. So I think you know, as we see the flood of GOES data come, we're also going to see other interesting types of imagery and information come and make it into the not only into the newscast and the weathercast, but make it into the operational forecast office to help with the issuing of warnings and the provision of impact-based decision support services.
Nope, I can't. I guess I can't screen. Can't find my screen.
You just got a show title there, Sheldon. Can't find my screen.
Yeah.
That'll be the show title for tonight. When I look at the COD at the College of DuPage site, you know, I see a shortwave window, band 07 on the 16th. It looks almost like a visible satellite. You can really determine the different clouds moving at different levels. Comment on that channel right there as to its value. Is that a combination of visible and infrared together, or what is that?
Let me see. I don't know. Oh, you know what? I just came up with a wildfire. Can I show that one?
Absolutely.
Okay. All right. Let me just share this here.
We're just in us guys territory here right now until James gets back, so we can say anything we want to say.
That's cool. So here's an example. Can you see this full screen of some wildfires? And I'm going to put this into motion. All those areas that are circled, there are fires that have started. And you can see those smoke plumes with 1 minute imagery.
Wow.
So it's quite amazing. You know, not to mention you can see currents and see all sorts of things going on. Look at the little cumulus fields that you were talking about earlier, Bill, in North Carolina, northern South Carolina. You know, the wave clouds in parts of Alabama or Mississippi.
Right.
There, where you can see those right beyond the wildfire monitoring banner. See those wave clouds, standing waves.
Yeah, I really was amazed at looking at the visible tonight. You know, after 8:30 Central Time, when that we're losing the light of the day in Washington and Oregon over into Idaho, almost continual for hundreds of miles. Wave patterns set up at obviously fairly low levels that I don't know that I've ever seen that before. And when you put it in motion, it really changes your perspective.
Oh, it does. And when you put, picture's worth 1,000 words. A GOES loop is a stack of Bibles. I mean, it's really amazing when you see the influence that orography, topography have on the weather, and then to map it to pictures from the ground, where you can show a picture from 22,300 miles out, and then a viewer or somebody sends a picture in saying, look at these wave clouds. You can map that one-to-one. And now the Twitter feeds are geolocated. You can put them right underneath of a cloud and start to explain to viewers and folks, what's going on, and start to relate satellites and the importance of satellites to helping us observe what's going on. So it's just spectacular. There are things being learned every single day when new images come down from GOES 16. It's truly going to revolutionize weather forecasting.
So Sheldon, if you had to rank all the great weather inventions over the past couple of centuries, starting with the telegraph, where's this one gonna end up?
Well, that's hard to say, but I think it's going to be up there with the current generation NEXRAD radar data.
I never thought I'd say that, but I think you're right. I think that's going to be true.
And I think that if we can get a microwave sensor on a geostationary satellite, maybe in 15 or 20 years, that just may surpass radar or may be even more comparable than radar in that realm of possibilities. But I think we all need to be able to use all the data in a very efficient manner and get and interpret it real well and get the information, hazardous weather information, out to the public. And I think we can do it in even a more efficient way so that more lives are saved. And that's pretty much the how we live our life these days. It's all about saving lives and property.
So Sheldon, you mentioned getting microwave sensors on these geostationary satellites. Why hasn't that happened to this point?
One of the big reasons is that the antenna for a microwave imager would be about 3 to almost 4 meters, and that has been at least 10 years ago. Everybody was saying that was technologically not feasible. It may be a little bit more feasible now, but it would be a very, very expensive proposition. So what people are now thinking about doing is launching all these little polar orbiting satellites, like 12, 18 of them, so that you can have almost continuous microwave satellite information, so that it almost replicates what would be the case with a polar microwave sensor on a geostationary, and may cost less. So hopefully that'll become a reality in the next 10 years or so.
So are there any capabilities on this satellite over the tropics, especially to pick up wind speeds at the surface?
Other than I guess the wind vectors that will be produced by this satellite, like with other geostationary satellite imagery and loops, and because of the higher resolution and the more frequent refresh rates, you'll get more and more low-level winds for the clouds that are pretty much down near the surface of the oceans, and in conjunction with the scatterometers that are on the polar orbiters, that should help immensely improve wind speeds closer to the centers of storms.
That's going to be something to look forward to. Yeah. So you got something you're champing at the bit to share there, Dave?
Well, this is just the visible satellite picture using GOES 16.
Yeah,
so you're seeing the just phenomenal extent of wave clouds that are developing because of the strong westerly winds. And you can see the surface stratus coming around, Seattle and coming on shore in the Pacific Northwest there. But the upper level winds are coming across the mountains and creating, look at that, just a standing wave clouds from the Cascades all the way across Idaho into Montana, into Wyoming, where you see some blow off of some thunderstorms that are there. It's just, I mean, you can see some of the snow melting in the Sierras, when you look at 1 minute imagery. Whenever you have snowfall, and of course, how can you miss the severe storms that are in Kansas right now that are forming and as the sun goes down, but you see all sorts of dynamics happening. So, it's kind of like the weather for us over the last several years has been a storybook where we turn the page and we get model output by the hour or whatever. And GOES 16 is adding chapters worth of information between each page. And we have so much to learn and so much to observe. It's just fascinating, and it's going to give everybody an opportunity to tell more stories about how dynamic our weather is, how tough it is to forecast, how important it is to communicate it more effectively. And people love this stuff. I'll tell you, the more you can put on TV this information, the more it becomes must-see TV.
So when the satellite is positioned, I guess it's being moved to where it's going to be kept in place, and maybe y'all can fill me in on what the real terms are, but where will it be located and how far will it see from latitude to latitude, basically?
Yeah, so it's right now, because of testing, it's over the center part of the country. It stays over the equator, so it either moves to the west, 135 degrees west, or to the east to 75 degrees west. And so it's going to be, once it goes operational in November, it's going to become GOES East. There was a lot of pool money being put out there from people saying, is it going to be GOES East or GOES West? And I was one of the ones that thought for sure it's going to become GOES East because it's such a revolutionary satellite. It's got to be out there for not only hurricane season, but to show the benefits of the forecasting and observing capabilities all up and down the coastlines. But once it becomes operational, then it will be sending this imagery back. And one of the things that NOAA is going to do for the eclipse, there are two different sectors you can take, like a mesosector. If you're familiar with the type of sectors that they can zero in on severe weather, they're called mesoscale sectors, and they can go into super rapid refresh mode where you can get imagery every minute on the current GOES satellites. With GOES 16, you can identify two mesoscale areas in the country, take 1 minute imagery, and never lose the scan of the whole world every 5 minutes. So what they're requesting for the eclipse is to take both of those severe weather sectors, overlay them on the same location along the path of totality, so we can get 30-second imagery of the eclipse.
So that's in effect how we get 30-second imagery then.
That's how we get
the two mesoscale sectors simultaneously.
Exactly. Now, how often will that be possible? Because, what's the likelihood of severe weather happening somewhere in the U.S. on August 21st? I think it's probably there somewhere, and much less a hurricane. So the current request is out there to do 30-second imagery of the eclipse. However, if there's severe weather, there'll be a sector pulled away, and we'll have 1 minute. And
so Sheldon, will this satellite be able to track Santa Claus?
No, but Santa Claus will be very in tune to looking at this data, especially since all the geostationary satellites across the world will have pretty much the same type of sensors, and he'll also be tuned to the polar orbiting microwave data, because he'll need to know where the moisture plumes and the atmospheric rivers are to stay clear, so that they don't send the fire hose to douse him in different parts of the world.
So surely the polar satellite can track him now. I mean, come on, Sheldon. At least the North Polar satellite.
The matter of fact, that polar orbiting satellite goes over Santa Claus's house every 102 minutes. So
how does our new satellite compare to Himawari that we've heard so much about? How are they similar? How are they different?
Oh yeah, that's a great question. By the way, I've been holding this hot topic right here. I'm just going to pull it up, but I can't hold it for too long. But this is GOES 16 has a bunch of solar observatories on it as well. So we'll be watching that. I have to let it go. So put that over there. And by the way, we also have an animation right here, and I'm going to show you a real animation for how we can look at the sun with GOES 16 and how we're going to be able to observe it. So we'll be able to see, all that red, and then a different sensor to see all of the solar dynamics that are going on, which is actually pretty cool. But what was your question?
I can't remember. It's getting so late. Aubrey, jump in whenever you can. I know you're probably in show, so okay, good. All right, that's will make sure you have the opportunity. Just take over whenever you can. So Himawari, I guess we were talking about.
Yeah. Himawari was up there first, and it was launched by the Japanese, and it was built. That sensor ABI was built by Harris Corporation, the same company that built ABI. The only thing differently that the Japanese did with Himawari is that they added a green channel, so they actually do have true color imagery in their sensor. The U.S. dropped the green channel because they figured that they can derive it with the other channels. So that's the only difference, not really noticeable by the naked eye, just technically that's the difference. And both satellites are pretty amazing. We can now take Himawari data and display it in the Western Pacific, which covers Hawaii. So we can see all sorts of typhoons that are forming out there, and merge it with GOES data. So now we can see, particularly now since GOES 16 is over the center part of the country, the Himawari and GOES West or GOES imagery sometimes intersects. And so you can get some overlap and see how they're observing. So that's what's going on with the Japanese, and they're going to be launching another one as well.
One thing I may add is that Australia, before Himawari went up, only got satellite images every hour. The Japanese would only do a full scan down to Australia once an hour. When Himawari went up, now Australia started seeing satellite data every 10 minutes. We think of the improvements between 15 and 5 minutes with GOES, between GOES 13 and GOES 16, but the Australians, and they do get some severe weather occasionally, especially with tropical disturbances that affect them, now are able to get Himawari data every 10 minutes.
All right, so Sheldon and Dave, what are your favorite sites right now to look at the data on? Share some of those.
Well, I do like the College of DuPage's site, right now, because it's very, it's interactive. You can choose some different things. I mean, I just switched over here to the mid-level water vapor. So just watching that go on, I think what we're really seeing, and it's just phenomenal. I mean, this should be artwork on the wall that just gets broadcast onto everybody's wall every night. It's pretty awesome. But I think what we're going to see is the importance of different observing systems coming together on the same map at the same time. And when that happens, all of a sudden it's building up everybody's knowledge of what's going on in the atmosphere on one screen. And so, it's pretty phenomenal when we're going to be getting updates from satellite faster than we get them from radar.
Mm-hmm.
Right? We don't get 1 minute updates with radar. We get 6 minute updates, when, and maybe a little bit more frequently in severe weather mode. But I think the future is in combining data sets that are being produced by different subject matter experts that are making their data available in real time in web services. So then you can just pull any agency, any company, any organization's data together on your system on the web. And that's basically going to give you AWIPS in a web browser. And it's going to be pretty phenomenal when that happens. So I don't think we're too far from it. I think, the colleges and universities that are, Wisconsin, there's such a tremendous archive and a tremendous processor of satellite data. CIRA out in Colorado has tremendous data as well. The folks that Sheldon worked with at NOAA STAR, they're putting up some really cool imagery and research products that when you look at, it's like, oh my gosh, why can't this be made operational? But it takes a while to get there, to put into operational streams. But I think if you were to look at GOES data now and you wanted to see some of the different layers, I think the College of DuPage website right now is pretty good.
You concur, Sheldon, or do you have another one you'd like to tout there?
Well, the other one is the Sierra Colorado State has a pretty good GOES 16 website, but mostly just visible and for the mesoscale sectors. But the NASA Sport real-time satellite imagery has a website for GOES 16 ABI, especially the CONUS section, where they have or just about all the channels there, and you can click on the different channels and also animate so you can learn more about what the different channels look like and just learn what you could use and things like that. Unfortunately, I'm not able to screen save where I'd show you some of my imagery, but like Dave, the College of DuPage has a very flexible site where you can go to 2 sectors for 1-minute data. Unfortunately, today they had an area over Baja there, so I couldn't save any of that data. But the 5-minute data, they have all different sectors over the U.S. with the various products that you can click on to see what it looks like. And so it gives a forecaster a chance to get comfortable with the data, use the data, even though it's not quite operational yet because it's still being tested out because it's a new satellite. But everybody should be ready to use it once it becomes officially operational in November.
All right, now, Dave, if you see Span come back, you have to be quiet. So you go silent if Span comes back. You know, they don't let us talk about climate change on this show, but I know you've done the Glenn Gerberg Weather and Climate Summit for a long time. Talk about that, what it is, and give us a couple of minutes about it.
Sure. The Glenn Gerberg Weather and Climate Summit now is in its 32nd year. I've been associated with about 28 years. And we basically bring together scientists and broadcast meteorologists from around the country. And we put them in Breckenridge, Colorado in January. And we talk about serious issues, weather technology. We talk about extreme weather, its impacts on communities around the country, how they can become more resilient. We talk about space weather. We talk about we do talk about a changing climate. We talk about the science. We bring in scientists that have drilled for ice in Greenland. We talk about the impacts of sea level rise. These are all real things, and it's nothing. We talk, and all the videos actually are online on the YouTube channel that you can see. The really cool thing about the Weather and Climate Summit is that we give all the speakers 90 minutes. 90 minutes to talk about their expertise and what they're finding. And we stream it live, and we have a satellite truck there. So we supply the capability for all the broadcast meteorologists to do their shows live back to their stations, to interview the speakers, to interview those folks who have put out their presentations that day. We keep everybody together for 4 days so we can build camaraderie and build relationships. So if somebody needs to call Dr. Jim White at University of Colorado to talk to him about how fast Greenland's melting, then he knows him. He gets on and can either do a live on-air interview or something on a phone. And so this is really a pretty amazing effort. And what we're doing actually, which is kind of like a second announcement, but it's not really official yet, is that we're working on taking the Extreme Weather and Community Resilience Summit on the road to make it a regional effort.
So have you already found your location for that, Dave?
Pardon me?
Have you already located your spot you're going to do that at?
We have a number of people who want a location, but we're not really, we can't really announce anything because it hasn't come together yet. And we also have sponsors that are interested in making sure that we cover particular extreme weather events in parts of the country. I mean, for example, I spent quite a bit of time talking with Rick Knabb about the Southeast and how are people going to understand the new products that the Hurricane Center is putting out. So one of those regional summits will be in the Southeast. We'll talk about resilience for communities to sea level rise. It's happening. Pictures of roads flooding in Georgia in the middle of the day on a sunny day that never used to flood before. And it's something that, you don't want to step back and say, oh, that's not happening, because it is, and it's impacting transportation, it's impacting cars, it's impacting communities. So what are the things that can be done to help prepare those communities? And
so Dave, are y'all able to factor out and filter out the polarization that seems to have sort of gridlocked the issue to a great degree?
Well, I think we have some great presenters that have talked about this. Jim White is excellent. He was featured in Chasing Ice with James Baylog on Nova. He talks a lot about free will and what you want to believe in and what you think you have to believe in or what your choice is. And so we get into a lot of good discussions there, but we really do stick to the science. And what are the observation systems and what are the people on the ground seeing? And what are these satellites from NASA? Project Icebridge is incredible. They flew a radar over Greenland, and this radar is identifying liquid water lakes that are underneath the ice cap in Greenland. And if that water finds its way to the ocean, it's going to blow away any sea level rise estimates because that liquid water was never discovered before. And so it's already liquid form. So when you see somebody like Deke Arndt talk from National Centers for Environmental Information, NCEI in Asheville, formerly NCDC, and he talks about tracing people and their lives and their heritage in the Corn Belt of the Midwest, and how changing climate and extreme weather has impacted their livelihoods, what they're able to harvest, what they're able to grow. It's certainly something that impacts people and impacts viewers. And if you live in Kansas and you don't care about sea level rise, just remember that 90% of the food gets distributed through our river and water networks.
And those ports that might be underwater when it's all said.
Those ports. And some of those cruise ships are clearing some bridges by inches now.
And Dave, I can tell you a story about doing a workshop in Tulsa, Oklahoma, and forecasters saying we don't need to know that there's moisture in the Gulf of Mexico, and these Gulf of Mexico moisture plumes can go all the way up into the upper plains, so that everybody in the United States needs to know about the water vapor as far as 1,000, 2,000 miles away. So in the way of the atmosphere.
Absolutely, it's so critical, and all we want to do with these summits is to connect experts with broadcast meteorologists so they can learn from each other, get stuff on the air, tell good stories, have good graphics and information, and be different, right? I mean, I travel around the country just like all you guys do, and you turn on the weather. They're all using the same weather system. They all look the same.
Mm-hmm. And they're using the same consultants.
Well, you can thank consultants. You're right. I remember when I was when I was at NBC in Washington. This is funny. The consultant took me into a conference room. It was my turn. I thought she was going to talk about my competition on the other channels and say how I could differ from them to really make myself different and stand out. The first question she asked: "How long have you had that mustache?"
Because that's what matters.
That's what she asked. And she said, if you think, I said, I've had it since the 6th grade.
There you go.
So don't mess with my mustache. But
according to James, it's only changes in facial hair that breed distrust. So that was what we learned last week on WeatherBrains. So anyway, you're in Bethany Beach, Delaware right now.
Yes.
That town was obviously impacted heavily by Hurricane Sandy. Have you always been going there? Have you seen the before and afters, or is this kind of a one-off trip to that place?
Oh, no. I have a place here. And so it's my East Coast research location for sand dunes. And I can tell you that they're in bad shape right now. The blizzard that we had 2 years ago in January took away 3/4 of the sand dunes on the Delaware, southern New Jersey coastlines. And this coastline right now is incredibly vulnerable.
Mm-hmm.
And they were just approved for emergency funding, federal funding for beach renourishment that's going to happen in the fall.
That may be too late.
It could be too late, very easily.
With those warm sea surface temperatures off the East Coast, that's not good.
No, it's not. So there's a lot of I've been coming here for the last 40 years when my parents rented a house in Bethany Beach. But it's really, every time I go to the beach, I look at the sand dunes and then I watch people walking up and down the boardwalk. Then I look at the sand dunes and I look out into the ocean and think, nobody realizes the power of the water and how easily it could breach those dunes. And hopefully they'll get them built back up. But that sand's just going to be taken back out again when we have another storm, and we will. Wow. Right? We have the East Coast snowstorms, and we have the hurricanes that just come up the coast. So it's not just here; it's everywhere.
Remind me tomorrow, Dave. I need to talk to you about an event we have coming up associated with the National Weather Association in September. That there might be some synergy there. So maybe we can talk about that tomorrow. Aubrey, you're unmuted. Is that a good sign?
Yes, I am free from all the shows. I'm the only meteorologist, pretty much around. Anyway, so I did have two questions. So basically for both Sheldon and Dave, 15 years ago when you guys were looking at, some advancements in technology, did you ever think that this was going to be possible? Did you say, in the future, I think we're going to be able to do this? Or is this just kind of just so unbelievable you never imagined?
I'll let you go, Dave. All right, I'll go. As an operational satellite meteorologist, I really was only just concerned about getting the data that I had now, and really didn't have a chance to think about what the future was going to be. One thing that I was at least one of the pioneers at was developing the polar orbiting microwave products, the total precipitable waters that have led to the quote unquote atmospheric rivers of moisture that are so well known now. So I knew, and I really caught on to the microwave aspects of polar orbiting data. Even back into the early 1990s, I knew that was going to be a big future in filling some of the geostationary things that we couldn't get from those types of polar orbiters. But the capabilities of current GOES 16, I didn't think about 1 minute or 5 minute regular 5 minute imagery I was just happy getting what I was getting without a geostationary data. But the polar microwave, something different to complement the geostationary, that's what I really was interested in, and I worked with people at universities to help produce those types of products that now are in operations, and kind of the way they look pretty much like geostationary data. It's just that they come from polar orbiting satellites.
Yeah, that's great. I agree with that, Sheldon, and I think when I think about the future and put myself back 15 years ago, I've always thought about how to get data more accessible and in front of people so they can have better situational awareness. They can have better decision-making capabilities. And I've always thought about how can you get the data sets that are available and bring them together, because it's interesting when you talk to any federal agency, particularly NOAA, because they put up operational observing systems in space and on the ground. Particular program managers for each one of those areas think this is the be-all and end-all, right? When the Weather Service went through their modernization, they had NEXRAD radars out there. Man, this is going to solve all our problems for severe weather and prediction and warnings and all that stuff. But what's tougher is to get everybody to understand that they are an important spoke in that wheel. But it takes the wheel to make that overall situational awareness much better and that forecasting to get improved. So bringing those observing systems together, like GOES 16, my gosh, it's phenomenal. and it's updating faster than radar data. So how do we really bring those together and other observing systems together to help you, communicate more effectively on the air? And the other thing that's really challenging is, and this is just going to escalate more and more and more, particularly with the cloud out there, how do you discover new data that's out there that could help you do a better job tomorrow at 6 p.m.? You might not have any idea that that data exists today, but you want to know about it tomorrow. So how are we going to make data discovery easy so you can just touch a button and it's more topic relevant, right?
Right.
There's a tornado chance today.
Yeah.
I'm going to hit this button and all the data dealing with tornadoes is going to appear on my screen. That's the kind of thinking that I've had, that I'm trying to bring into the future. And, it's not there yet, but, places like Twitter and social media with hashtags and all that stuff are making it easier to harvest relevant information that you can then turn around and communicate. The only problem with that is it trusted? Is it trusted data that you can make those decisions with? So that's the kind of stuff I'm thinking.
And to add what Dave said, I'll occasionally check some Twitter people on Twitter that I know, and if they're talking about a particular weather situation or and I know of a piece of satellite data like a scatterometer winds over the water. They can help them with additional information to help them with their forecast. I'll just put a little blurb, less than 140 character blurb, and put the URL of that particular product. And many times they'll come back and say, I didn't know that even existed, and that's helped me.
That's what I said. Yeah. That's exactly what I told you when you were starting to spew all your cool links and stuff. I'm like, I had no idea this was out there. I didn't know I could do this, and look at this. And I know there's a lot of other meteorologists I've talked to. We've talked about you before and said, have you seen Sheldon's cool stuff? Like, what he tweets about and everything. And it's so cool. And that's why, we kind of wanted to have you on tonight to get, we can see the images, but sometimes, it helps to have a little bit of that background knowledge that you have. To explain those a little bit more to us. So I think the show tonight was so helpful. And I know I missed some stuff, but I can't wait to go back and watch tomorrow night and see everything that I missed. But you guys may have talked about this. What is your, either the mind blown feature of Go 16, or, what do you think is just like the coolest thing that, I didn't really know we, could really do this?
Well, for me, it's the rapid refresh of the imagery and the ability to slice through the atmosphere. So you have basically 3 levels of moisture channels that you can now look, and that's going to be just amazing for severe weather development, for looking to see where the to match the 850 chart, the 700, look at those winds and match them in with that particular layer in the atmosphere. So to me, mind blown for GOES-R was number one, experiencing a launch. When we had our GOES-R workshop down there, it was incredible. I have a slow motion video of the launch in 4K.
Wow.
That we shot down there. And having the other broadcast meteorologists that were there, and just, they are forever bound now to GOES 16 because they felt that rumble of the launch when it took off.
So were you just holding your breath, Dave, when it was taking off?
Oh, it was just amazing. I mean, all that work, right? Like Sheldon said in the beginning, 15 years.
Yeah.
Even more it took.
I was standing in a Rooms to Go store in Hoover, Alabama, watching it on NASA TV on my iPhone. And before it was over with, people thought I was looking at the football game, so they came over to see what was going on. And when they saw it was a rocket, they were more interested in the football game.
Well, they kept delaying it, right? How many times did it get pushed back?
Oh
like
my
15
gosh.
minutes?
It was, I mean, talk about suspense. It launched in, it was delayed, by weeks and weeks. And then the night of the launch, it was delayed It was delayed until the last minute of the 1 hour window that we had. And so we were all thinking, come on.
The suspense is killing us.
The suspense is killing us. And
it reminded me of the Syracuse UConn game several years ago that went into like 9 overtimes. And you're going, come on.
I know. And then to see, it go up and it disappears and all the adrenaline that you've had. And I'm trying to get, so I encourage all the broadcast Mets out there that are going to be watching this to send me an email, dave@stormcenter.com. Send me an email and say, are you going to be able to do a workshop for GOES S? So we can get down there and cover the launch of GOES S, because we'll have so much more data. NOAA is thinking about doing something else, that probably won't generate as much, interest from the media. We had a 3-day workshop with tours of Kennedy Space Center and all sorts of really cool stuff. And we're trying to get them to do it again because they think that there won't be as much interest because it's the second one.
You can put me on the list.
And I'll tell you,
we're going as a B team, won't we?
We'll do a WeatherBrains field trip.
I'll tell you,
live broadcast.
Do a WeatherBrains live from Kennedy Space Center.
Yeah, and Bill, since GOES S is going to be the Western satellite, and the
how do we know that? Should we put some extra money on it becoming the GOES East? No, not going to happen, huh?
GOES 16 is the East satellite. GOES S should be the Western satellite, I would presume. And since the NWA is going to be out in California, what a perfect venue to gather a whole bunch of support for people going to Florida for that launch of GOES S.
There's actually going to be some sort of launch on that early Thursday morning of NWA.
Yeah,
like 3 o'clock in the morning, and
that's JPSS-1.
Right.
There's going to be a special session if everything works out. We don't have tons of delays. Obviously, there could be delays.
That site has been in the making since the mid 1990s, when it was decided that the military and civilian satellites would be coming together. So that JPSS is even longer time coming than the GOES R was, but.
So we're going to put you, Sheldon, in charge of making sure it launches on time so that we can have our special satellite session at midnight that early Thursday morning. So
there's a picture that I took of the launch of GOES R, which was just phenomenal across the lake there. And seeing that smoke go out, and I have a video, and it's not worth showing. Maybe I'll show it at AMS, with Greg Mant standing there watching it go up, because I said, look, I need a NOAA executive to stand with our broadcast meteorologist so we can get sound bites from him as soon as that thing goes up. And he said, it's so exciting to see that engine start and then to watch that rocket go up, after all these years of work. And it's just incredible to see it, and then to see the imagery from it. It's just nothing like you've ever seen. And this is the place where we had one part of the workshop. We had it at the Kennedy Space Center Visitors Center, where we had free run of the place, but we also had organized presentations on what happens with the rocket before it goes off, with the gassing and fueling and all that stuff. And then what happens when the satellite launches itself, when it separates from the stage, and then how does it start to send back imagery? So, to have that kind of experience is all pretty cool.
That's some heady stuff. So. Well, Aubrey, we're approaching the record length of show here if we haven't already established.
You know what? We could probably do 2 or 3 continuants, because this stuff is just, it's just incredible. It's fascinating, and it really reels you in, which is why the show's lasted obviously so long for tonight.
Well, I'm so
and Dave and Sheldon, you guys have been fantastic. So thank you very much.
Thank you
Yep.
for
Thanks
joining.
very
Well,
much. Yep.
I thought, no, you're not going to get away that easy, Dave. You're going to have to pick of the week here. I was going to hang out for spam, but obviously he's driven home and forgotten us over here. So we'll be doing the sports scores here in a minute. But so we'll go around the big mahogany table real quick. We'll start with Aubrey. Aubrey, what's your pick of the week?
Mine is the website, the astronomy picture of the day, and today's it's still today for another few minutes, was it's the red sprites. And I have to say, I'm just obsessed with the red sprites, the blue jets. Just so mysterious and fascinating. It's just a really cool image.
Well, I'm personally a fan of Diet Sprite, but the red sprites are not bad either. My pick of the week will be the Noah Star website. I've heard that mentioned, and I like that website. So that's going to be my pick of the week. And I have to promote some of our future guests. Really thankful to have our guests tonight. Next week, we'll have that'll be on Monday, June 26th. We'll have Mike Oblinski talking photography. We'll have Dr. Patrick Marsh at WCM at the Storm Prediction Center on July 10th. Greg Stumpf will be on talking about the Research to Operations Nexus meeting that will be held as part of the National Weather Association annual meeting in Anaheim in September. We'll be excited about that. Mike Collier from the new site Weather Battle. This is going to be a FanDuel type set up for weather forecasting. He's very excited to be on, so we're really thrilled about that. Very excited today to learn Dr. Judith Curry agreed to be on Monday, August 7th. She'll have just issued her new hurricane seasonal forecast. That'll be fun. And we've been working really hard to get Leah Daly on. She's going to be on Monday, August the 14th. And Aubrey worked really hard to get Damon Lane from Coco on. And we've got an invitation out to him from Oklahoma City to appear on Monday, July 3rd. And so we've had a hard time filling that pre-holiday schedule. So
do we need to get another OKC meteorologist? Do I need to?
We'd love to have them on.
Let me see what I can do. See if I can put some bugs in some ears.
Yeah, I know one that probably won't be on, but that's okay. We'll take as many as we can get.
I'm not sure. We're gonna have to talk later because I'm not sure who you're talking about.
Not obvious or anything like that. So anyway, those are my guests that are coming up now. I've stalled for as much time as I could here. Sheldon, did you come up with a pick of the week?
Pick of the week. I guess with Go 16 College of DuPaix, I've been looking at it quite a bit. Also, when Go 16 becomes operational, we'll have to go to my former agency, OSPO Anestis, which will produce the data and show it on the web. So I always have to remember my former colleagues there.
Absolutely. Well, if you spend much more time on that website, they're going to start charging you rent.
Right.
So it really is a great website. They do a fantastic job. Dave, thank you for hanging late with us tonight. What's your pick of the week?
Sure. Well, mine is, as you can probably guess, don't look at this without this.
Absolutely.
Nice.
So make sure you have your eclipse glasses if you're going to the path of totality. And we'll be putting on a webinar about the eclipse and all the support we're going to be offering to broadcast meteorologists. So hopefully you'll request to be a member of that eclipse group. And you have to tell me your TV station because it's only broadcast Mets. And we're also going to be communicating to every radio station in this webinar across the country. This eclipse is a big deal. It's not just going to be an awesome experience if you're taking off to go see it, but it's going to be a major emergency management challenge across the entire country with transportation impacts. So we'll be using Go 16 and we'll be using traffic flow monitoring and all that sort of stuff to give all the broadcast Mets enough information to keep their viewers informed. Thanks a lot for having us.
Yeah, it was great.
Thank you. Yeah,
great.
Thanks for all the information. It's going to be a lot of fun. But WeatherBrains is the weekly netcast that's all about weather. It's hard to imagine that we're approaching our 600th episode.
Wow.
We've been doing this for over 11 years now and having a blast every week doing it because of great guests like we had tonight and great listeners that give us lots of support. So we thank each and every one of you for listening or watching, however you're consuming the show. When you get it next Monday night, the 19th, But for all the gang here at WeatherBrains, I'm Bill Murray, the guest booking officer, wishing you and your family a great week ahead. Thanks, and see you next week.
Yep. Take it
All
easy.
right.
All
Well,
right.
we officially broke the record, guys, for longest show.
Okay.
All right. Just like Bruce Springsteen.
Exactly. I figured we hold them for 5 more minutes. I wanted Span to come back and see.
I know. How long's the show? Is it an hour show?
Yeah. Yeah, we're heading to a 3-hour show here now. So.
Right.
I think he's in his car heading home.
Yeah, I think he's probably going to be home and turn off the Hangout and go, "What the heck happened here?" So anyway,
All right.
thanks, guys. Thanks, Aubrey.
Great show. Thanks, guys.
Thank you very much. Take care.
Okay. Bye.
Bye.